Hello everyone, welcome back to the video. So today we're going to be looking at our states of matter, specifically how can we distinguish a solid, liquid, and gas from each other based on shape and volume. Your do now is what is the difference between a physical and a chemical property. You do not have homework tonight, so a little hint on that do now. My classroom door is brown. My classroom door also corrodes when an acid comes in contact with it. How do I know that it corrodes? Simple. Or it corrodes as a response of the acid. Simple, because chemical properties, we don't know them until we see our subject reacting. So quick question before anything else. Using your iPad, find two characteristics of a liquid. What did you find? You should find that a liquid has an indefinite shape but a definite volume. But my question to you, is a cat a liquid? Now, you might be thinking, oh, Ms. Wiswall, of course a cat is not a liquid. A cat is a solid. Well, yes, that's a short answer. But believe it or not, a physicist actually won the Nobel Peace Prize in 2017 for trying to find out if a cat is a liquid. And again, he did this in the Improbable Research, which mixes humor and science. So the reason why he researched this was simply because of our definition of a liquid. Our definition being that that it has a indefinite shape but a definite volume. The problem with that definition is that it's not necessarily 100% accurate, if you get what I'm saying. It's, we could apply a lot of things to that statement as being something with a definite volume and an indefinite shape. And technically cats follow the logic, if it fits, I sits. So that would mean that if a cat has a spot they want to sit in and they think they're going to fit, they're going to sit in that spot. And they're going to conform their body to the shape of that spot, as you can see in the images. So why am I telling you about this? The reason why is because I love telling you about goofy science. But the other reason, the main reason, is because these definitions, though they are very useful, shouldn't really be taken 100% because they can be misinterpreted or they can be misconstrued to, define something else, like this cat being a liquid, even though we know cats are solids. So what are the three states of matter? Very simply, your three states of matter are solid, liquid, and gas. Now, on each of the slides that are going to be coming after this, what I would recommend that you do is I'd recommend that you copy down anything that I write, or just copy anything I write and copy down the definition. Alrighty. So first, a solid. Now, first thing I want you to know is that a solid symbol is the letter S. So if you see a letter S next to a compound or an element, that means that that's in a solid. So for example, NaCl S tells you that that's solid table salt or solid salt. Now, solid has a definite shape and an indefinite volume. So for example, I include this image over here that shows a yellow cube trying to be shoved into a circle hole. Why doesn't it fit? The reason why it doesn't fit is because that cube has a definite shape. Its shape will not conform to its container, so it will not fit. By the way, to draw the particle diagram, what you would do is first you make a box. And you want to make sure the particles are as jam-packed together as humanly possible. And that would be your particle diagram for a solid, which you might be asked to draw. Hint, hint. Now think about this particle diagram. Despite the fact that these particles are jam-packed together, the truth of the matter is they are constantly moving. Specifically, these guys are just vibrating. Now when you draw these particle diagrams, you don't need to draw the little vibration marks. I just want to show you they're vibrating. There's only one state in which your particles completely stop moving. And that state is absolute zero, which is 0 Kelvin. That's when all motion stops. We have not reached 0 Kelvin yet. We've gone very, very, very close, but we haven't reached it. Next one is a liquid. Now, liquid can be denoted as either a lowercase l in parentheses or a script L in parentheses. For example, H2O, liquid. That's telling you it's liquid water. A liquid has an indefinite shape, but has a definite volume. So for example, if you take a look at this image I found in my education textbook, you see this little girl sees Jimmy, little boy, sees two containers with the same amount of liquid, same volume. But the moment that liquid is poured into a taller glass, it conforms to its shape. So again, it's still the same amount of liquid, but it is a different shape. So indefinite shape, a definite volume. Also, to draw this particle diagram, what you would do, again, you draw your little box. Now, these particles are not as jam-packed as your solid. They're a little spread out. So that is a liquid particle diagram, or what I'm looking for. What's a gas? Now, let's say that I decide to become an evil villain. Bwahahaha. That is a little bit of a toned down evil laugh, but trust me, the evil laugh from today's lesson is amazing. Anyway, so let's say I was an evil scientist and I had a gas, a poisonous gas inside a little box. And I told you that once I release this poisonous gas, it will hypnotize everyone to do their castle learning extra credit all the time. Ha ha ha! I know, terribly evil. So, at the moment before releasing this poisonous gas, the gas inside that little box has the volume and shape of the box. But once I open it, the gas suddenly takes on the shape and volume of the room, its new quote-unquote container. The thing you should know about gas is that gas will spread as far as it can once it is out of its container. And again, a gas takes on the shape and volume of any given container. Another way you can think about this, I know we've experienced these people before, the people who work out really hard in gym, they smell themselves and go, oh, I don't smell good. So what do? They cover themselves in Axe body spray, and then they go to class. As soon as they step in the room, how long does it take for you to smell the Axe body spray? Probably not that long, maybe about a couple seconds. Again, that is the gas that's coming out of that aerosol can. It's trying to go from the volume and shape of the aerosol can to the volume and shape of the room. That's why that smell spreads out so fast. By the way, the symbol for a gas is the letter G, a lowercase g in parentheses. So for example, HE, G, that tells you that's helium gas. And your particle diagram, you want to make sure these particles are as spread out as they possibly can be. So that is what we do. Quick question. Under the same conditions of temperature and pressure, a liquid differs from a gas because the particles of the liquid blank. Now the first choice says they're in a constant straight line motion. That is actually not correct because both of these particles, liquids and gases, move in a constant straight line motion. Now what does that look like? For those of you who may not be able to visually imagine it, good question. The best comparison that I found was actually a DVD menu screen. So as you can see, that DVD is just moving straight from one end to another and then bouncing off and keeps going with its straight, constant motion. So that's what I mean when I say a constant straight line motion. B, they take on the shape of the container they occupy. Now we went over that a liquid and a gas have an indefinite shape. So because they both have this characteristic, B is out. C, they have no regular arrangement. C is also out. The reason why is because these particles Because of the fact that they have so much space, they're able to move around constantly. The only one that has a regular arrangement would be a solid. So your answer is actually D. They have strong forces of attraction between them. Specifically, you should know from your strongest to weakest attraction points, your solid is your strongest, your liquid is your second strongest, and your gas is your weakest. Now, the fourth state of matter is known as plasma. I include this nice picture of a cat touching a plasma lamp so you can see his little paw glowing. But plasma is a little bit different from your other states of matter in that plasma can conduct electricity all the time. If I have to say which state of matter it most closely resembles, I would say that plasma most closely resembles a gas. And again, it's a gas that can conduct electricity, and that's actually how a plasma lamp works. Oops, sorry. Pretty much, in this plasma lamp, you've got your plasma gas, and you turn on your lamp, an electrical current goes through it, and that's what causes these really cool blue and pink little electric bolts. And you might be wondering, well, Miss Wiswall, why is it when I touch the plasma lamp, my hand lights up? That's a good question. We're going to get more into that when we get to our covalent and ionic bond unit. But that is a good question that I want you to keep in mind. Now, how can we distinguish a compound from a mixture with these states of matter? That's a good question. Basically, anything that is a solid, liquid, or gas is considered a substance because that's the only thing in there. Solid NaCl only has NaCl. Liquid water only has water. Gaseous helium only has helium. Meanwhile, a mixture can be represented as something known as an aqueous solution. Now, what does the word aqueous sound like? Sounds like agua. Agua means water. So, what an aqueous solution is a mixture with a substance and water. So, for example, NaCl AQ is just salt water. Now, which of the following is a mixture? If we look at all the choices, we want to see the one that is a mixture. MgOS, not a mixture, it's just MgO. Br2L, nope, that's just bromine 2. CaSAQ, well, that sounds like a mixture. It's both CaS and water. And an NEG, it's just Ne. So your answer is CaS because that is showing you a mixture of calcium sulfide and water. So now what I'd like you to do is I'd like you to go to the exit ticket, and on the exit ticket today it is asking you in terms of shape and volume, what is a solid, liquid, and gas? Once you are done with that exit ticket, you may stop playing the video, and as always, thank you for listening, and I hope you all have a wonderful, wonderful day.